We will now look at maximum range. How to find maximum range? Range, it means Sx, horizontal displacement. Okay, maximum range means maximum Sx. This is what they are trying to say. Okay, it can be shown. You can see the appendix for derivation. It is not in the syllabus, but if you want to understand, you can look at the appendix. Right, for maximum range, the angle is 45. Right, which means in the ideal situation, for example, in standing board jump, you want to jump the furthest, you should jump at an angle of 45 and it will bring you to a largest range. If you jump at a bigger angle, you will end up nearer. If you go lower, you will also end up nearer, right? So the maximum range is 45 degrees. This is what you need to know, okay? But it is for your information only. A level seldom tests you, so usually they will tell you. Okay, the other aspect is alternative angles for projection. For a body to achieve a particular range, so a specific Sx, it can be projected at two possible angles with the same initial U. That means to say, if I need to hit this target at Sx away, I can project it at this angle here, let's call theta, or I can project it at a larger angle, 90 degrees minus theta, and it will have the same range. That means it will still hit the target. This is, the assumption is the initial speed is the same for these two. Right, so let's watch a video.
Crusader's remarkable technology also allows the crew to execute devastating multiple-round simultaneous impact or mercy missions. After receiving the fire mission, Crusader calculates the time that one volley at a given trajectory will take to reach its target. It then launches additional rounds with alternate trajectory paths and charges calculated to reach the same target simultaneously. A single howitzer can drop nearly 1.5 tons of steel on a target at the same time. Imagine the impact of an assault executed by a battery of Crusaders. In 3 minutes, 6 Crusaders can deliver 7.5 tons of hot steel on the target. Crusaders' attack is so swift and so accurate that the enemy has no time to escape or retaliate.
In the video, you can see there are many trajectories that can give you the same path. Right, there are at least 4. Why is it so? Isn't it supposed to have only 2 possible angles? Remember, this 2 possible angle is for the same initial speed u. So in the video, this might have different speed. Therefore, you can take different paths, different angles to give you the same range. Okay, that is the horizontal displacement. Right, but if we have the same initial speed, there are only 2 possible angles, which is theta and 90 degrees minus theta. Let's look at one example. Work example 15. Right, if we have a ball projected with a speed of 17.5 at the angle of theta, it hits a ground target of 20. Right, so this is Sx, or we call the range. Determine the possible values of theta. Right, so we can use this equation. This is from the appendix. You don't have to memorize this. If you are told to solve a problem, they will guide you to derive this, or they will just give you the equation. Okay, but so far A level has not been tested on this under the new syllabus. So what you need to do is just apply the values. The range is 20, U square is 17.5, and G is 9.81. You just need to find theta now. Okay, solving sine 2 theta, and you find that theta is either 20 or 70. This is now the last section of projectile motion. We're looking at the effect of air resistance. Remember, for projectile motion, how do you describe the path? What are the characteristics? Right, we have two paths, a horizontal and vertical. Both of them are independent to each other. Right, and in the horizontal, the acceleration should be zero. That's why it's constant v. In the vertical direction, a is equal to g equals to 9.81. So this is the case where there's negligible air resistance. What if we have air resistance? If we have air resistance, then an object moving in this direction will face a resistance, so it will decelerate. Therefore, A is not equals to 0. Right? Similarly, in the vertical direction, there is the weight that is pulling it down, and there is also air resistance in the downward motion, the air resistance. So, in this case, the acceleration is not equal to 9.81. Right? In the upward motion, if it's moving up, the weight is moving down, the weight is downwards, acting downwards, air resistance is also downwards. Right, so A is also not 9.81. In a nutshell, when we have air resistance, it does not fulfill the two conditions of A equals to 0 in the x direction and A is constant in the y direction. Therefore, it will not be a projectile motion. And hence, the path will look very different. You can see the blue path here. Right, so these are the three characteristics that you have to take note. Firstly, the maximum height is lower compared to a projectile motion without air resistance. Secondly, it has a smaller range compared to the one without air resistance. Lastly, it is not symmetrical. So if you draw from the highest point, you will notice that on this side, it is steeper. Right? If you look at projectile motion on both sides, it should be a mirror image. Okay, so this is the end of the chapter on projectile motion. You are now ready to do the tutorial questions and as well as assignment. Please complete the assignment by next Monday.